Hello, today we will be looking at sketching parabolas using the turning point form. Now, if we look at the turning point form, this is something that you can actually get it by completing the square. And what is the turning point form over here? How does it look like? If I were to do a quick highlight over here in orange, this is actually the turning point form where you got y equals to a times x minus h holding square plus k. Now take note, whenever you complete the square, there is always a perfect square. And that's the reason why we call complete the square. So the perfect square is this part over here. This is the perfect square over here. And if you think about it, as the phrase suggests, right, the turning point form, what it means is that you can get the coordinates of the turning point very easily. And if you look at it, the h and the k value are going to be the coordinates of the turning point. So let me give a few examples. If I have y equals to 2 times x minus 1 square plus 5, the turning point itself, it's going to be 1, 5. That is the coordinates of the turning point. If I have y equals to 2 times x plus 2 holding square plus 1, the turning point itself, it's going to be minus 2, 1. Take note that if this is a minus 1, this becomes a 1. If this is a plus 2, it becomes a minus 2. And this is related to how the whole graph was being translated horizontally, which translation is a separate topic on itself. And if you look at the y coordinate, if this is 5, this will be 5. If this is 1, this will be 1. So if I were to look at the turning point form, I will be able to get the coordinates of the turning point directly. Now, why is the turning point important? This is because, right, whenever we are supposed to sketch a parabola, or in short, a quadratic curve, we need to include a few characteristics of the curve on the sketch. The first thing that you will include, it will be making sure that you get the correct shape. So shape is one very important thing. It's going to be either a concave upwards curve or a concave downwards curve. Sometimes we call it a happy face or a sad face. Now, the second thing that you want to include is what we call the axial intercepts. And that is your x-intercepts and your y-intercept. And just a very quick recap, if you want to find the x-intercepts, you let y to be 0. If you want to find the y-intercept, you let x be 0. And lastly, you got to indicate the coordinates of the turning point on the curve itself. All right. And let me just share with you how I'm going to sketch this curve. I have y equals to x squared minus 4x plus 8. So the first thing to ask myself is, what is the shape? Is it going to be a happy face or is it going to be a sad face? Now, if we look at the coefficient of x squared, the coefficient of x squared is equals to 1, which is going to be more than 0. So it's going to be a happy face shape. So that's the first thing. We know that it's a happy face. And how about finding the axial intercepts? So let's think about it. If I were to find the y-intercept, that is to let x be 0. So if I let x be 0, I get 0 squared minus 4 times 0 plus 8. And I will get 8. So I know that the y-intercept is 0, 8. And if I were to find the x-intercepts, you will let y be 0. And if you let y be 0, you will end up with x squared minus 4x plus 8 equals 0. Now, this is the time that, again, you can't factorize. So if you can't factorize, what do? We will actually try to complete the square. All right. But do we need to complete the square at this juncture? Probably I will complete the square using the expression. over here, because I also at the same time I want to make sure that I can write it in the turning point form. So if I keep the first two terms, I take the coefficient of x divided by 2, squaring it, minus away the same value. And the reason why we do that is because the first three terms becomes what we call the perfect square. So if I were to write it in the perfect square form, it will be x minus 2 holding square minus 4 plus 8. And if I were to highlight this portion here, these first three terms, it's going to be your perfect square. And this will simplify to become x minus 2 holding square plus 4. Now at this juncture, I want you to think about what is the turning point. So if we were to see that the turning point, based on the turning point form, it's going to be 2, 4. And why is it 2, 4? Let me just highlight to you. This is 2. I mean, if you look at the turning point form, this is x minus 2 holding square. So the x coordinate of the turning point will be the opposite of minus 2, which is going to be 2. And the y coordinate of the turning point, it's going to be 4. So the turning point is 2, 4. Now, before we attempt to find the x-intercept, we want to ask ourselves, if I have an x and y axis here, the turning point is at 2, 4, which is here. And the shape of the curve is like that. It's going to be a happy face, it's going to be concave upwards. There is no way for the curve to cut the x-axis at all. So essentially, it means that there are no x-intercepts. So, which means that I don't even need to find the x-intercept. Now, having said this, what I would do is, this is a rough sketch. I know the shape of the graph. I know where the position is. I will now attempt to sketch the graph. To sketch the graph, you got to make sure you draw the x and y axis. And I suggest a good technique will be to sketch the graph first before you write down all the other coordinates of the intercepts of the turning point, because that will ensure that you get a nice shape. What I would do is I will sketch the graph. This is going to be a happy face, and the turning point here, it's going to be 2, 4. The y-intercept, it's going to be 0, 8. And lastly, I will just need to make sure that I write down the equation of the curve here, which is y equals to x squared minus 4x plus 8. And that's all you need to do. And that's all for now.